Use the definition to find the derivative of f of x equals 1 over x squared minus 4. Then evaluate f prime of 4. The first thing to do is write down the definition of the derivative. F prime of x equals limit is h goes to 0 of f of x plus h minus f of x divided by h. The next thing to do is to formulate what f of x plus h is. And that means to take f of x, 1 over x squared minus 4, and replace the x's with an x plus h in parentheses, and that'll give us 1 over x plus h squared minus 4. Subtract from this f of x, and then all of that's over h. This is a 0 over 0 indeterminate form and will continue to be until we can take an h in the numerator, factor it out, and cancel with the h in the denominator. In order to get an h in the numerator to factor, we need to combine the terms in the numerator together, and they are fractions, which means we are going to make use of the common denominator method for the 0 over 0 indeterminate form. So our next step is to get the common denominator. The first fraction has a denominator of x plus h squared minus 4. The second one has an x squared minus 4. The common denominator will be x plus h quantity squared minus 4 times x squared minus 4. So I'm going to take the first fraction and multiply it by x squared minus 4 over x squared minus 4, a form of 1. I'm going to take the second fraction and multiply it by x plus h squared minus 4 over x plus h squared minus 4, a form of 1. All this is over h, and that will produce our common denominator. Now we'll multiply the fractions. The first fraction, multiplying the numerator, 1 times x squared minus 4, all over. And in the denominator, I'm going to multiply those expressions, but I'm not going to FOIL them out. I'm going to keep them factored. But they are multiplying each other. Second fraction, that'll be a 1 times x plus h squared minus 4, all over that same common denominator of x squared minus 4 and x plus h squared minus 4, multiplying each other. We will not FOIL that out. All that is divided by h. The next step is to combine those fractions. Since we have a subtraction, that negative is going to distribute onto both of those terms in the numerator, so be careful to do that. So f prime of x equals limit as h goes to 0 of x squared minus 4 minus x plus h squared, and then minus a negative, so plus 4. We have to distribute that minus sign. All over x squared minus 4 times x plus h squared minus 4, and then the entire denominator is an h. Now in that numerator, we can cancel out the negative 4 and the plus 4. And furthermore, we can expand the x plus h quantity squared and then distribute the minus sign. We're going to want to do that because we may be able to combine more terms together. So we will have limit as h goes to 0 of x squared minus x plus h times x plus h, all over that denominator, x squared minus 4, and x plus h squared minus 4, and then the entire thing is over h. So we have the limit as h goes to 0 of x squared minus, foiling that out, that'll give us an x squared, a plus xh, a plus hx, which will be a 2hx, and a plus h times a plus h is a plus h squared, over x squared minus 4, x plus h squared minus 4, and all of that over h. Now we're going to distribute the minus sign into this entire expression. That'll be our next step. So f prime of x will equal limit as h goes to 0 of x squared minus x squared minus 2hx minus h squared all over x squared minus 4, and then x plus h quantity squared minus 4, and then the entire thing divided by h. We can combine together like terms in the numerator. There's an x squared and a negative x squared, and those will cancel. The other two terms will remain as is. Now, because we have a fraction in the numerator, we're going to need to take the denominator fraction, reciprocate it, and multiply it. Well, the denominator right now isn't a fraction, but it can be made a fraction by calling it h over 1. And now we can reciprocate and multiply. And we will have then negative 2hx negative h squared divided by x squared minus 4 times x plus h squared minus 4, and then this times 1 divided by h. In which case we can multiply the numerators, and that'll give us negative 2hx minus h squared, and we can multiply the denominators, and that will give us h times x squared minus 4 times x plus h squared minus 4. So we can see the h that's in the denominator, and in the numerator every term should have an h in it because we're going to factor an h out. That'll be our next step. And we'll have limit as h goes to 0. Factoring h out will give us a negative 2x minus an h, and all of that is divided by h times x squared minus 4 times x plus h squared minus 4. Those h's can cancel. And we finally have removed the 0 over 0 indeterminate form. I will just rewrite what we have left, which is a minus 2x minus h in the numerator, and x squared minus 4, and then an x plus h quantity squared minus 4 in the denominator. And we can now, that we no longer have the 0 over 0 indeterminate form, put a 0 in for each of the h's. In the numerator, that'll give us a negative 2x. In the denominator, that will give us x squared minus 4 times, now x plus h, with h being a 0, will just be an x. So that will be also x squared minus 4. And we have a negative 2x over x squared minus 4 squared. There is your derivative. The only other thing left to do is to evaluate f prime of 4, which just means to plug a 4 in for the remaining x's. And that will give us a negative 2 times 4 divided by 4 squared minus 4, quantity squared. Negative 2 times 4 is a negative 8, divided by 4 squared is 16, minus 4 squared. 16 minus 4 is a 12, so we'll have a negative 8 divided by a 12 squared, which is a negative 8 divided by 144. 144 is divisible by 8. It's 8 times 18. So the 8 and the 144 can cancel out to be a negative 1 over 18.